All right, everybody, this is Mr. Bear, and I'm going to talk to you today about how to graph a quadratic in standard form. So this lesson kind of builds from what we did last time. Last time we were looking at the vertex form, which looked like this. And from this form, we were able to read off the vertex as h comma k. And that was one of the nice things about having this format. When we are looking at standard form, though, the standard form does not allow us to read off the vertex very easily. So we're going to talk about how we can do the graphing pieces like we did last time, but when your equation is in standard form. Okay, so let's talk real quick about what the standard form does. The A value tells us the direction of the graph. And we talked about that last time. They're the same in both forms. Okay. So it tells us the direction, up if positive, down if negative. But it also tells us the width of the graph. So it'll let us know if the graph is narrow, wide, or standard. It's wide if the absolute value of your A is less than 1. So think of it as A value is getting closer to 0. If there is no A value listed, meaning that it's just an understood 1, then it's a standard width. And then narrow as A is getting further from 0. So then the absolute value of A is greater than 1. Okay. The vertex, there's a formula that you're going to be using, which is negative B over 2A. Sorry. And so that's why you have to know from the standard form what your A, B, and C values are, because you need those to help you do the vertex. After you find the x coordinate, you're going to plug whatever you got into, you're going to plug it into your equation to get the y coordinate, okay? For the y-intercept, you replace the x's with 0, and you'll see that in standard form, the c value, this value right here, is going to be your y-intercept. Because if you replace the x's with zeros, the ax squared and the bx term just are 0. So all that's left is c. So the shortcut way, when you have standard form, your y-intercept will be 0, c. Okay, so with that, let's go ahead and look at some examples, okay? All right. So let's look at a couple examples here. On the first one here, let's start with the direction. Direction, we're looking at the A value. Looking at the A value, and since our A is an understood -1, the graph is going to open down, okay? The width, we look at the absolute value of A. Come on, this thing is being silly. The absolute value of A in our case is absolute value of -1, which is just 1. So that means this is standard. Okay. For the y-intercept, we look at the c value, and we're going to write it as 0, comma, and our c here is -1. Now for the vertex, we need negative b over 2a to get the x coordinate. Okay. So in this case, that's -6 over 2 times -1. So I'm just replacing the b and the a from our equation. And that gives us -6 divided by -2, which is 3. Now remember, that is just the x coordinate of the vertex. So we have to find the y coordinate now. So that 3 that we just got, we're going to plug it into our equation. The way I like to do this is I like to write what that equation looks like with just blank spots for the x's so that I can replace them with the 3 that we got. Okay, and to do this, I'm going to change color Let's go with this. So I'm going to replace the x's with 3's. Following my order of operations, on this first term, only the 3 is getting squared, so 3 squared is 9. That negative that's in the front stays in the front. 6 times 3 is 18, minus 1. Negative 9 plus 18 will give me positive 9, and 9 minus 1 makes 8. So the vertex coordinates, so now we can finally get to the vertex. The vertex is going to be 3, 8. Okay. All right, now we're going to do the same thing, but we're going to do it with a different equation. Direction for this one, again, look at your A value. A is positive, so it opens up. For the width, we use the absolute value of A. Absolute value of A is 2, which means this is going to be narrow. Y-intercept, look at your C value, and it's going to be 0, 7. I should have labeled my A, B, and C so you know what I'm talking about. For the vertex, start with your x-coordinate. So we're going to do negative B value over 2 times the A value. My B is already negative, so we're going to have a double negative. My A is positive, but that doesn't really matter. So we get 12 divided by 4, which is 3. So coincidentally, we have an x-coordinate of 3 again. For the y, we are going to plug in 3 everywhere we see an x. So again, I like to leave blank spots for the exponent, or not the exponent, the variable. Okay. And now I'm going to use a different color. Let's go back to that red. Replace the x's with 3's. Now, if you do not feel comfortable with your order of operations, just use a calculator for this. It's a 36. Okay. 2 times 9 is 18. 18 minus 36 is negative 18. Negative 18 plus 7 makes negative 11. So we now have our vertex. For the vertex, we're going to have 3, negative 11. Okay. All right, so that is what we can do. And now on the back side of our notes, we are going to actually graph some quadratics. Okay. Okay, so now to graph a quadratic, we just basically have to put all of this together. So first we find the vertex. So for my vertex, I'm going to have negative 4 over 2 times the A value, which is just 1. So that's going to be 4 divided by 2, which is 2. By the way, if this video goes too fast for you, please remember that you may pause it. For the y coordinate or the f of x coordinate, we're just going to plug in 2 for the x's in our equation. Oh my. Oh, I don't know what's happening. What is happening? I did not do that. I have no idea what I just did there, so I'm going to have to figure something out. Not sure what just happened, but oh well. Here, I'll just start it from here. Sorry, it's all zoomed in like so. That's going to give me 4 minus 8 minus 5. 4 minus 8 is negative 4. Subtract 5 more, you get negative 9. So our vertex is going to be at 2, negative 9. Okay? So that means that on my graph, 2, negative 9, I'm going to plot that point right here. And remember, we also have that axis. Oh my goodness, I don't know what's going on here. Stop. Hold on, I think I figured out how to do that. There we go. Okay, back to normal. Remember, we have this line of symmetry that occurs here with our vertex point right down there. Now we're going to make a table of values, and I like to include the y-intercept in my table because that just means less calculation. But 2, negative 9 is going to be in the middle because we always put our vertex there. Do this as I do it. Sorry, this is a little bit slow. Let's see, so I do 1 and 0, and then I do 3 and 4. Just like we did the last time, we want to get the values that are surrounding the vertex. Since x is 0, I can make my y-coordinate for that be negative 5. That's the y-intercept. Okay? So 0, negative 5 is a point that I'm going to plot. Oh, shoot, it's doing this again. Stop it. Sorry, technology can sometimes be wonderful, and then sometimes it can be annoying too. Which is why I'm on the camp of I don't always need technology. Okay, oh, good golly, why is it doing this again? Come on. Okay, so sorry, everybody. This is really frustrating, I get it. All right, so I have that point plotted, and by symmetry, that means I'll have 4, negative 5 as well. So 4, negative 5 is also going to be a point here. Now all I have to do is plug in either 1 or 3 to my equation, and I think I'm going to choose to plug in 1. So I have 1 squared minus 4 times 1 minus 5. Using a calculator will be your best bet there. When I work that out, I'm going to get 1 minus 4 minus 5, so it'll be negative 8. So those are going to be negative 8s. So we have 1 negative 8 and 1 negative 8 and 3 negative 8. And we can just go ahead and make a graph. Okay? All right, and that is generally how you graph a line or a quadratic. I am not going to do examples 3 and 4 only because this thing is just being ridiculous, but I wanted you to at least see an example of how to graph. So now you're going to do your skill check and then see what happens from there. I will check your skill checks to make sure that they work out okay.